I'm going to do my best to talk my way through this one for you guys. I went ahead and filled it all out. So we have a height of an object thrown upward, modeled by the function, and it's given here, a quadratic function. H naught is the initial height in feet, and V naught is the initial velocity in feet per second. So then you have this question, a situation, a ball is projected directly upward from an initial height of 80 feet with an initial velocity of 112 feet per second. So that's telling me H naught is 80, so I filled that into the equation, and 80, and V naught is 112. Now, if you think about the shape of this graph, notice it's negative and it's a quadratic. So I expect to see a picture that looks something like this. So in the next part, they ask you, after how many seconds does the projectile reach its maximum height? What is the maximum height? Well, the maximum height is going to occur at the vertex. So we have a formula to find that. The opposite of b over 2a. So I take negative 112 divided by negative 32, and I get 3.5. And that would be seconds because that's t. So if that's in 3.5 seconds, I can plug that into my height function, and I get 276 feet. So that tells me that the maximum height is 276 feet after 3.5 seconds. On the next part, they ask you for what interval of time is the height of the ball greater than 240 feet. So I actually graphed, I used an X instead, but I graphed my function. It's not showing the negative sign. There was a negative sign. I graphed my function in Y1, and I graphed 240 in Y2, and this is the picture that I got. I set the window. X min, I have a 0, and X max, the scale, Y min, Y max, the scale. Now, I knew the 3.5 in 276, so it wasn't a guess when I guessed 300, when I put 300 for the Y max. I already knew the maximum height, so I made use of that. Then on my graph, and I think I still have this here, I did second, calc, and then I did intersect, number 5. And then you can actually, it will ask you for the first curve, and if you hit enter, and then the second curve, hit enter, and then your guess, hit enter, and it tells me the intersection so I can see if it's 5 seconds. It's when it's at 240. Move the cursor over to the other side, over to this side, and do the same thing. Second calc, intersect. And you get the 2 and the 5. So notice that my curve is above 240, in between 2 and 5. So that's what I would say for my answer. On part D, after how many seconds will the ball hit the ground? You want to set your height function equal to 0 because the height is 0. You could factor out a negative 16 out of this to make the numbers more manageable. It was not factorable. I did the quadratic formula. I got about 7.65 seconds. The other answer is negative. The other option you could have done is on your graphing calculator, you could graph this and do second calc 0 and come up. And as long as you are explaining, these are modeling problems, so you set it up, but you can use your calculator to actually solve that. The next problem, a soft drink vendor at a popular beach analyzes his sales records and finds that if he sells X cans of soda pop in one day, and it gives his profit. So profit is how much he makes after his expenses. So again, it's an upside down parabola. It's a parabola that opens down. So when it asks for the maximum profit per day, that's going to occur at the vertex. So you have to find the vertex. Opposite of b over 2a gives me 1,500. Remember, that's the x value, and x represents the cans. You plug the cans in to find the profit. So if he sells 1,500 cans, he makes $450 profit. If he sells 0 cans, plug in a 0, you get negative 1,800. That means he loses $1,800. His expenses for buying the pop and having the machine, and he didn't sell any. Break even means that your profit is 0. So you want the profit function equal to 0. So it's kind of like having the projectile hit the ground. It's the same problem. I just did this on my calculator. Not the class one, but my personal calculator. I plugged this in to Y1, and then I just did second calc 0. You will have to adjust the window, but we know the maximum height is 450, so you can adjust it so you can see all of the graph. And then I did second calc 0, and I got about 829 cans, or you can solve it. and I think that was right. I didn't double check. The next example I have on another video, so go there and look at it.